guys, we are starting our little unit over systems of inequalities just because we didn't get to it before winter break. So we're on pages 1 and 2. First, we're just going to learn how to graph a linear inequality. So Jake, we're on page 1 and 2. Jake and TJ are solving the problems below. Show each solution and answer A through B. So we have Jake, who has negative 6x plus 2 equals 14, and then TJ, who has negative 6x plus 2 is less than 14. So let's just go ahead and solve the first one. So for Jake, we would subtract 2 and get negative 6x is equal to 12. We would divide by negative 6. And x would equal negative 2. So the only answer for Jake is negative 2. Then we have TJ, which again we would subtract 2. Oopsie. Which is 12. Then we would divide by negative 6 as well. But because we divide by a negative, we have to remember to flip that sign. So negative 6, when we divide by negative 6, become x is anything greater than negative 2. Okay. So list some similarities between TJ and Jake's problems. Well, I followed the same steps, solving the same way, solving using the same steps. Some differences. If I think about Jake's answer, the only answer for Jake is negative 2. So Jake has one answer, which is negative 2. And then we have TJ. If we think about x being greater than negative 2, there's an infinite number of answers because there's an infinite number of numbers that are greater than negative 2. So I'll say a lot of answers. As long as it's greater than negative 2, it's going to be a solution. Oopsie. Okay. While graphing linear equations and inequalities are going to be very similar to one another, there's some very key differences as well. Just like when we graphed just regular inequalities like this, we would do an open dot and we would shade to the right to show all the possible solutions. Just like when we start graphing lines, it's going to be very similar. So if necessary, we will solve the inequality for y. And then use the y-intercept and the slope to plot points on the line. So again, we want it to look like y equals mx plus b, because that's the way we mostly like to graph lines anyway. But now we just won't have an equal sign. We're going to have an inequality symbol. Then what we'll do is we will have to draw this line. So just like here, we would have an open dot. Because it can't actually be negative 2. Dependent on the symbol right here, we're either going to have an open line or a solid line. Okay, so if we think about if this would be an open dot or a solid dot, basically we're going to either have an open line or a dashed line or a solid line. Okay, so we would have, because this is not or equal to, this is just less than, we would have a dashed line. For greater than, just like how we would have an open dot, it would also just be an open line or a dashed line. For this, if this was just a regular inequality, less than or equal to would be a closed dot because it could include that number or include that point. So we will have a solid line because it can include that number. And then greater than or equal to, we will also have a solid line. Okay. Then again, if we had something like x is greater than negative 2, we would shade to the right because it's everything that is larger than negative 2. So if we think about a line on a coordinate plane, we are also going to have to be shading as well. So if we have something like y is less than something, we are going to shade left or down. We'll kind of talk about what that means here in a second. If it's y is greater than something, we are going to shade up or right, less than or equal to. Okay, again, we're going to shade to the left or down. And then greater than or equal to, we will shade to the up or right area. Okay, something to note, the solution set of a linear inequality includes all ordered pairs in the graph's shaded region, as well as on the line if the line is equal to, or I guess I should say is solid. That makes more sense. Points on a dashed line are not included in the solution set. Okay, so we'll kind of compare this solution as we actually graph a line. Okay, so here's -2. X is anything that is greater than -2, but not including -2. So now we're going to actually graph not just on one number line, we're going to graph on a coordinate plane and kind of see the differences, because these are all the numbers that are greater than -2. And so if we have a coordinate plane, that's basically just two number lines. And so we're talking about now ordered pairs. Okay. So for these ones, we are going to graph them and then kind of check our solutions to make sure that we are correct. Okay, so y is greater than x plus 3. So the first thing is, let's just graph x plus 3. So we're going to start at 3 and go up 1 over 1, up 1 over 1. And I am going to make sure that I put all the points that I can. Okay. Then all of the things I need to know is from this symbol right here. Okay, first I ask myself, is it including this line or not including this line? Okay, it's just greater than, it's not greater than or equal to, so it will be a dashed line. You can write dashed if you want. Okay, but I'm just going to kind of draw a dashed line because it cannot include actually that line. Okay, so basically we just did the dot on a number line. Okay, now we have to do the shading part of the number line, but now we have a coordinate plane. So the way I do it is I put my pencil on the y-intercept, okay, and then I read it out loud. Y is greater than x plus 3. So I need to shade greater than this line, okay? So here's the line. I need to shade above it, greater than. Okay, so now to check it, okay, what I'm going to do is I'm just going to use the point 0, 0 a lot of the time, because 0, 0 is an easy line for me, or excuse me, an easy ordered pair for me, and it'd be really easy to substitute it. So I'm going to check 0, 0. Okay, it's not in the shaded part right now, so after we check it, it hopefully will not make sense to our solution. So y is greater than x plus 3. So I'm just using 0, 0 as my x and my y. Okay, 0 is greater than 0 plus 3. 0 plus 3 is 3. Is 0 greater than 3? No, that's not true. Okay, so this is a false statement, which makes this true because this part of the line, this part of this region is not shaded. So all of these ordered pairs, if we were to plug it in, should not make sense, which means that all of these ordered pairs, if we were to plug it in, should make sense. You could check this point right here, 0, 6. Y is greater than x plus 3. 6 is greater than 3, which is a true statement. So all of these ordered pairs should also make sense in this for this inequality. All right, for the next one, y is greater than or equal to -2x minus 4. Again, I'm just going to graph it like normal. Start at -4, go down to right 1, then go backwards. Then I think of this symbol right here. It says greater than or equal to, so it's including. So I'm going to use a solid line. Okay. Then again, it's not an equal sign, it's an inequality symbol, so I need to shade. So I'm going to put my pencil on the y-intercept, and I'm going to read it again. Y is greater than or equal to this line. So greater than means above, so I'm going to shade above. All right, just to check, I'm going to check 0, 0. Now, if I see it is in the shaded part, so hopefully this makes a true statement. 0, 0. So y is greater than or equal to negative 2x minus 4. Negative 2 times 0 is 0. 0 minus 4 is negative 4. Is 0 greater than negative 4? That is true. So that means that this half plane, this region should be shaded because all of these ordered pairs would make true statements. Okay, y is less than negative 4. So this is one of those weird equations. It's missing something, so it's either a hoy or a vux. Because it has y something, it's a hoy, so it's going to be a horizontal line at negative 4. So I'm going to start at negative 4, okay? And it's less than, so I need to have a dashed line. Okay. Now it's not or equal to, it's less than, so I put my pencil on the y-intercept and I go less than, so down. So this would be the solution to this inequality, all of these ordered pairs. So I could check 0, 0. Again, you could check one that's actually shaded if you like, but this should be a false statement since it's not shaded. So y is less than negative 4. Well, that's not true. That's false. Okay? And so that shows me that I have shaded it correctly because it is not shaded. Okay. All right, numbers 4 and 5. And these will be the last couple that we do together on this video. We have 2x plus 3y is less than or equal to 18. So this one is not looking like y equals mx plus b. We're not ready to graph it. So the only thing we have to do is basically just solve for y. So I'm going to move the 2x over. And again, if you guys can do this in your brains, you don't obviously have to write it all out. Okay. Now I'm going to divide by 3. Okay. I did divide by a positive number, so there's no need to flip this symbol or anything. So y is less than or equal to negative 2/3 x. 18 divided by 3 is 6. So now it looks like I am ready to graph this. So I'm going to start at 6. I'm going to go down 2, right 3, down 2, right 3, then go backwards. It's less than or equal to, so the line should be a solid line. Okay, and then it's not an equation, it's a less than or equal to, so I put my pencil on the y-intercept. It is everything that is less than or equal to, so I need to shade less than this line. So this is a big shade. Okay. If I wanted to check it, again, I'm going to check 0, 0 because I like that one. It is shaded, so hopefully it's true. Y is less than or equal to negative 2/3 x plus 6. Negative 2/3 times 0 is 0. 0 is less than or equal to 6. That is true. So I have shaded it correctly. Okay, number 5, we have 6x is greater than 2y minus 10. So I need to solve for y. You could move the y over and then move the x over, or you could move this stuff over there. I don't care. As long as you're just consistent and you feel confident about it. So I'm going to move the 10 over. 6x plus 10 is greater than 2y. Okay, then I'm going to divide by 2. So basically I'm just moving everything else to the left, which did not have to be the way you did it. Okay. So I have 3x plus 5 is greater than y. Okay. Now if you don't like the way that looks, if you'd rather be y equals mx plus b, just make sure that the symbol is greater than to this stuff. So when you rewrite it, it needs to be greater than that stuff as well. So if you flip it, make sure you also flip the symbol. So we would start at 5. We would go up 3, right 1, and then go backwards Okay. It is less than, so it is a dashed line. Okay. And then for shading, y is anything that is less than 3x plus 5, so it's less than this line. So it's anything lower than this line. Okay. For the check, again, I'm going to use 0, 0 when I can. Y is less than 3x plus 5. 0 is less than 5. That is true, so it should be shaded, and my goodness, it is. Okay, so for today, guys, I want you guys to try these problems, okay? And then there's going to be, I want to say, 5 Delta math questions that I want you guys to try. It'll look something like either these or like these, where you're just solving and graphing them. But I do want to make sure that you guys try these problems because we are going to go over them on the next day. Okay, so see you guys then.